this will be our video on section 3.1. Now, section 3.1 deals with derivatives of polynomials and exponential functions, i.e., it's the beginning of where we learn how to find the derivative using what a lot of people call the shortcuts, not the definition, right? Not the definition. So if we take a look at some of the problems, like problem number 9, right? Problem number 9, it says f of t equals 1/4 times t to the 4th plus 8. Now, the first thing we have to do, because we don't know how, we know that if we want to take the derivative of this, and there's a constant in front, right? One of our properties says if you want to take the derivative of this, you put the constant out front, and then just go ahead and take the derivative. I'm writing d with respect to t, right? The derivative with respect to t because my variable is t here. It's not d over dx because my variable is t. Go ahead and take the derivative of what's inside. Now, our derivative rule says we take the derivative of some function plus another function. Now, leave your constant. Our derivative rule says you're going to go ahead and take the derivative of the first function plus the derivative of the second function. Right? That's how we apply. We have a constant. We have a rule that says the derivative of a constant times a function. We can put the constant out in front, take the derivative of what's inside. Well, what's inside is a function plus a function. So that's the derivative of the first term plus the derivative of the second term. That's our sum rule. Now we're going to use our exponent rule here, right? So we have a 1/4 there. The derivative of t to the 4th, we bring down the exponent, right? We have that rule that says if we're taking the derivative of x to the n, we put the exponent in front, and our new exponent is found by subtracting 1. So I bring the exponent in front. My new exponent is 4 minus 1, which is going to be 3. We have another rule that says the derivative of a constant equals 0. We showed that in class. We showed why that was 0 because the slope of the tangent line to a constant is 0. So this is going to be plus 0 here. And we're going to get 1/4 times 4. That's 1. So we just get t cubed. Now, in the beginning, it's going to be easier for you if you actually write out the steps instead of trying to do them all in your head. Problem number 10. Well, in problem number 10, now we only assign 7, 9, and 10, but I would suggest you do as many problems as you want. Between 3 and 26, we only assign 1, 2, 3, 4, 5, 6, 7 problems. But between 3 and 26, there are 23 problems. So I would suggest, or 24 problems, actually, I would suggest you do as many of those as possible. We need the practice. Now, if you do the problems that are assigned and you're perfectly capable of moving forward, then you probably don't need more practice. So problem 10 is x minus 2 times 2x plus 3. And you and I don't know what to do if there's the derivative of a function times a function. We don't have a rule for that. If we go back and read all the rules in 3.1, there is not a rule for that. But that's not anything that we can't overcome because we know how to FOIL. We know this is equal to 2x squared minus 4 plus 3. So minus x minus 6. So we're going to take the derivative of that. So we're going to take the derivative with respect to x of 2x squared minus x minus 6. Using our derivative rules, that's the derivative of 2x squared minus the derivative of x minus the derivative of 6. Now there's a constant out in front, so we can put that in front. We're still going to take the derivative of x squared. Here we know the derivative of x. We have a rule that says the derivative of x is equal to 1. minus, we know the derivative of a constant is equal to 0. And now to complete the problem, we keep our 2. We take the derivative of x squared, which means we bring down the 2. Our new power is going to be 2 minus 1, or 1. This is negative 1 minus 0, so that's negative 1. And we get 4x minus 1. Again, writing the steps out for the first few problems, for those of us that are doing this for the first time, that's really going to help. For those of you that have taken a calculus class in the past, maybe you don't have to write the steps out. Okay. What about problem number 19? Well, just like problem 10 required us to multiply before we could move forward, problem number 19 requires us to divide before we can move forward. So problem 19 says y equals, and we have x squared plus 4x plus 3 divided by the square root of x. Now you and I do not have a rule that says take the derivative of a quotient. We don't have a rule for that. We're going to learn it in section 3.2, but we don't have it yet. So the only thing you and I can do to solve this problem is rewrite it as 3 fractions. We have a common denominator. This is our approach. So we have one more step, because for most of us, when we try to divide powers of x, radicals don't help us. We have to rewrite this as x to the 1/2 4x over x to the 1/2 plus 3 divided by x to the 1/2 before we can move forward. So there's a little bit of algebra before we can do the calculus. Now, x squared divided by x to the 1/2. Remember, when you divide, you subtract exponents. 2 minus 1/2. That's going to be 3/2. X to the first divided by x to the 1/2. We're going to subtract exponents. 1 minus 1/2. That's x to the 1/2. Here we have x to the 0. Technically, we don't write it, but it's there. So 0 minus 1/2. That's going to be plus 3x to the minus 1/2. And now we're going to move forward with taking our derivative. We had to do all of that before we could find y prime. Now I'm just going to apply the power rule straight up. I'm not going to write all the steps out for this problem. We bring down the 3/2. My new power is 3/2 minus 1. 1.5 minus 1 is 1/2. Here, I keep my constant out in front. I bring my power down. I subtract 1. 1/2 minus 1. That's going to be x to the minus 1/2. Here I keep my constant out in front. I bring my power down. Don't forget the negative. I subtract 1. That's going to be x to the minus 3/2. Now, what does this look like? Right? If we write this out, simplify this. This is a positive exponent, so that's 3 root x over 2. 1/2 times 4 is 2. So that's going to be 2. But that's a negative exponent, so that's going to be 2 divided by the square root of x. Here we get minus 3/2, and we multiply that out. And this is x to the 3/2 negative, right? Negative. So that's going to be 1/2 is the radical, 3 is the power. So that's going to be the square root of x cubed. You don't need to get a common denominator. So that's problem 19. In problem 29, right, we can work out 29 right down here, I think. We'll see if we can fit it in. Problem 29 says, find the equations of the tangent line and the normal line to the curve. And they give us a function. They give us y equals x to the fourth plus 2 e to the x. And the point that we're interested in is 0, 2. Now they want the equation of the tangent line, right? The equation of the tangent line. So we know the equation of the tangent line is going to be y minus y1 equals m times x minus x1 point slope formula. And we know that's going to be y minus my y value, 2, equals my slope times x minus 0. Now, the only thing left for us to do here is to find the slope. Now, we know how to find the slope. The slope is equal to the derivative. So we'll come down here and we'll find y prime. Y prime, we're going to use our exponent rule. We bring down the 4, we subtract 1. We leave our constant out in front. The derivative of e to the x by our rule in the book is e to the x. Now, we have to know not the derivative. This is the general derivative, right? We're good to go there. That's the derivative. That's the slope everywhere. But we're wondering about at x equal to 0. So y prime is going to be 4 times 0 cubed plus 2e to the 0, or it's 4 times 0 is 0, e to the 0 is 1, we get 2. So the equation of our tangent line is y minus 2 equals, our slope is 2, x minus 0 is just x. So we're done with the equation of the tangent line. Now they want the equation of the normal line. I don't know your past, and so I'm not sure that you know the definition of normal lines. Normal lines are perpendicular to the tangent line. That's what a normal line is, perpendicular to the tangent line. The slope of the tangent line is 2. So the slope of the normal line is perpendicular But what does that mean? That means it's perpendicular, negative reciprocal, right? Remember that from algebra? Parallel, same slope, perpendicular, negative reciprocal. So the slope of the normal line is equal to the reciprocal of the slope of the tangent line times negative 1. So for us, that's going to be negative 1/2. So the equation of our normal line is going to be y minus 2 equals negative 1/2 times x minus 0. Okay. That's how we do 29. Now on the next page, we turn the page and there are lots of words, but these are not word problems. We do not need to, have some kind of increase in anxiety over these problems. We just have to make sure that we translate the words into the math that we know. And we're learning about derivatives. Those are slopes. So we're just going to have to do our translation. That's where we're going to have to just take our time, read the problem, and take an opportunity before we start writing things down to translate the words and make sure we understand what we're reading. Okay. So if we look at a problem like 47, right? 47 gives us a function, f of x equals 5x minus e to the x. And it says, when is f increasing? But we know what that means. That means when is f prime greater than 0. Functions are increasing when their derivatives are greater than 0. So our job is to figure out when the derivative is greater than 0. We have to translate the problem into our language. Now we can find the derivative. That's 5. Derivative of 5x with a 5 in front. Derivative of x is 1 minus the derivative of e to the x is e to the x. That's our derivative. We want to know when this is greater than 0. Well, we all took algebra for a reason, so we could pass this class. We bring the 5 over here. We have minus e to the x is greater than negative 5. We divide by negative 1. We get e to the x is less than 5. Because when you divide both sides by negative, you flip the inequality. Now, we have to get the x out of the exponent, right? And that's what logs do. So we take the natural log of both sides. The natural log of e to the x is less than the natural log of 5. That is x. So the answer is whenever x is less than the natural log of 5. If we look at a problem like 49, right? It seems at first blush be kind of confusing, but it simply says, find the points on the curve, and they give us a function, 2x cubed, 3x squared, so we get y equals 2x cubed plus 3x squared minus 12x plus 1. And it says, when is the tangent line horizontal? Well, we know what horizontal lines mean. That means the slope is 0, i.e., what this problem is saying is when is the derivative equal to 0? Well, we know how to find the derivative of this. We keep our 2, we bring down the 3. So 2 times 3 is going to be 6. We take away 1. We bring down the 2. 2 times 3 is going to be 6. We take away 1. The derivative of 12x, the derivative of x to the first, we bring down the 1, so we get minus 12, and we get x to the 0. Now we want to know when this is going to be 0. We can factor out a 6. And now we factor. This is 6 times, and we factor this. We get x. We want a positive 1, so we get plus 2 minus 1. Now, we use what we called back in Algebra 1 and Algebra 2 the zero product property. If a function times a function equals 0, one of those functions must equal 0. So here we get x equals negative 2 or x equals positive 1. Again, it's about translating the problem, not panicking over seeing the words, okay? Now, they just keep adding things to the problems. They just want to make sure you're translating correctly. All right, so that was 47 and 49. Let's skip down to 55. I haven't read the problems yet. I'm just picking problems. Find an equation of the normal line to the parabola so that in 55, they give us a parabola, y equals x squared minus 5x plus 1. Plus 4, pardon me. And we know how to factor that. Why am I factoring? Because I'm going to draw a quick graph. I'm going to draw a quick graph so I can see what's going on here. This is x minus 4 and x minus 1. Now, if we draw that parabola over here, it opens up, x squared is positive, has an x-intercept of 4 and an x-intercept of 1. So here's 1, here's 2, here's 3, here's 4. It goes through here, and it goes through here, which means its axis of symmetry is right here, halfway between the two x-intercepts. and it opens up. So I'm going to draw this like this, just so I have an idea of what's happening with the problem. A picture makes things easier. It says find the equation of a normal line to the parabola that is parallel. And now they give me another line. Y equals, well, it's not even in the form of y equals. They're going to make me rewrite this. It's x minus 3y equals 5. Or negative 3y equals negative x plus 5. Or y equals 1/3 x minus 5/3. So the slope of my line is 1/3. Now, why do I care? Because it says it wants it to be parallel to this line. So they want the normal line to the parabola that is parallel to this line. Now, what does that mean? So it means it has to have a slope of 1/3. So it has to be normal, perpendicular, and have a slope of 1/3, right? Now, a slope of 1/3, right? A slope of 1/3 goes like this. It's not very steep, right? Rise over run. Run's going to be 3. Rise is going to be 1, right? Rise over run. So the slope's not going to be very steep. And we want to be perpendicular to our parabola with that, right? That's what it says. Perpendicular to the parabola, because it says the normal line. Or if we don't like this, this is the slope of the normal line. But we know what that means. That means its negative reciprocal is the slope of the tangent line. Right, here we go, translating words again, using our definitions. So the slope of our tangent line is going to be -3. So they want us to figure out where on this parabola, and I didn't draw this parabola with a scale, but they want us to figure out where the slope is -3. Okay, where is the slope on our parabola going to be -3? Well, we know what the slope of our parabola is. The slope of the parabola equals y prime. The derivative is the slope, and we can find that. We know what y prime is. Y prime is 2, right? We bring down the 2x. The derivative of -5x is -5. The derivative of 4 is 0. So that's the slope of our parabola. And we want to know when the slope of our parabola equals -3. So we solve this. We bring the -5 over here, we get 2x. Bring the -5 over, it becomes positive, equals 2, and we get x equals 1. It says find the equation of the normal line to the parabola that's parallel to this. So where is this going to happen? It's going to happen where x equals 1. Find the equation of the normal line. Well, now I know my point. X is 1. When I put x is 1 in here, I get y is 0. So that's my point. And we already know that the slope of the normal line is going to be 1/3. So we get y minus 0 equals 1/3 times x minus 1, or y equals 1/3 x minus 1. All these problems are about translating. Okay. Well, that's what I'm going to give you for your video on section 3.1.